Good morning and welcome to AP Statistics. Today we're going to go over how to answer the question that was homework, how to build a relative frequency histogram from the data set provided. Then we're going to talk about describing a distribution with a little mnemonic device that we call GSOCs, and then there'll be a homework assignment to discuss. So let's try to pick up right away. First thing you want to do when making a relative frequency histogram is you want to identify the range that you're working with. So in the range, in the data we had for the monsoon measured in millimeters of rainfall, the maximum value in that data set was 957. And the minimum value in that data set was 604. That gives us a range of 353. The next step when creating a relative frequency histogram is to decide how many columns or classes you want the histogram to have. I told you in the assignment that I wanted 5 columns or 5 classes, and if I didn't, I really should have, but I think I did. So because I wanted a 5-column histogram, I'm going to divide my range by the number 5, again, because I want 5 columns in my histogram, generally between 5 and 12. If you have a lot of data, you want more columns, but we didn't have that many points of data. So the class width, which I'll spell out for you here, is the range of 353 divided by the number of classes I want, which is 5, and that gives me 70.6. Now, I did say that I never, ever want to stick with the number I just got. No matter what the number is, we're always going to round it up somewhat, usually to the next half or whole. 70.6 rounds pretty easily to 71. So I'm going to call that a class width of 71. It's important to get the right class width. If you don't round it at all, you very well will probably run out of room for your highest value. If you round it down, which you never should, you will absolutely run out of room for many of your higher values. Never do that. If you round it up too much, it just looks awkward and you end up with a last class that is either low or empty. So 71 is a good rounding based upon the size of the numbers we're talking about. I wouldn't call it 75, that's far too much. 71. Okay, now we want to make what we call a frequency distribution, which is the table that allows us to build a histogram. Okay, so in order to make the frequency distribution, we're going to make, in this case, 4 columns, and we're going to call them class, and then tally, and then frequency, and then relative frequency. I'm going to make a table out of it. And obviously, because I'm working with a whiteboard, when I finish my frequency distribution, which you should also have made, I'm going to have to erase it to build the histogram, but that's okay, because you know what you're doing. The class begins with the lowest number in the data set, which was 604. It's going to go up to some number, but I'm not going to fill that in yet. I'm going to add my class width of 71 to the low bound. Now, 604 plus 71 is 675, which does not go here. It starts the next class, 675. Add 71 and you get 746, which starts the next class. Add 71 for 817, which starts the next class. Add 71 for 888, which starts the last class. That's 5 classes, so that's as far as I have to go. To figure out the end of each class, you're going to go one before the beginning of the next class. I can't go to 675 because if I went to 675 here and also started the next class at 675, where do the values of 675 go? Pretend you have 2 buckets, one that takes numbers 1 through 10 and one that takes numbers 10 through 20. Where does a 10 go? It can't have both buckets as an option, so we can't begin and end with the same value. Since that began with 675, this one ends rather at 674, one before it. And we keep going, so that's 745, 816, 887. The last value to maintain continuity is still going to be a distance of 71 from the previous ending value. Because as you might be able to see, did I goof on something? No, I didn't. We have values that are difference of 71 all throughout here also, not just the lower ends, but the upper ends. So what's 887 plus 71? That's 958. I know that the highest value is 957. I'm not ignoring that fact. But a histogram has to have columns or classes that have the same exact size all the way through. If you ended the last class at 957, it would be just a little bit narrower than every other class and wrong. It would look different where there's no reason for it to be different, and we call that misleading. So we don't do that. Even though I know 957 is the highest number, it has to go to 958 for continuity. Now, tally is when you go through the data and you just put check marks as when you see the values falling in the right range. I already did this, obviously. I'm looking off of my notes here. And I'm just going to show you what your tally marks should have looked like. There were 5 tally marks in the first, 5 tally marks in the second, 7 in the third, 4 in the fourth, and 2 in the last class. The reason why you have tally marks is you generally just want to go point by point, data point by data point, and put a tally mark whenever you see you have a point falling in a certain class. It just keeps it easier to keep track of. Frequencies where you write down what those tally marks add up to. So we got 5, 5, 7, 4, and 2. Now, in the previous video or class, I said that you want to also double check to make sure you've counted all your data. The symbol for the sum of is a capital Greek letter sigma. We're going to put a subscript of F for frequency. If you add up 5, 5, 7, 4, and 2, you get 23. And in the problem, it did say that there are 23 points of data in the monsoon data set that we are looking at. So that's good. It verifies we've counted all the data appropriately. Relative frequency is when you divide the frequency by the total count of the data. So 5 divided by 23. And that's 0.2174. And so is the next 5 divided by 73, 0.2174. 7 divided by 23 is 0.3043. 4 divided by 23, 0.1739, and 2 divided by 23, 0.087. I also said it's a good idea to add up all of your relative frequencies to see if you have something that is acceptable. If I add up all of my relative frequencies here, it's actually a perfect 1. 1 means 100%, so we've counted 100% of our data, which is our goal. If it is off by anything, it should be off by no more than a place value of 1 in the furthest decimal place you went to, because we're always going to strive for 4 decimal places unless it rounds earlier. Then that's 1/10,000th. Now in this case, it was perfect, no worries. Round off error is when it's 1/10,000th and it's appropriate and acceptable. More than 1/10,000th we say is bad. We made a mistake, something's wrong because something's been either not counted or overcounted and it's not good data. Okay, this is your frequency distribution. The most important values you're going to look at here are the first and last column because that's what's going to let you build your relative frequency histogram. I'm going to erase mine right now. Hopefully you've written yours down. If not, pause and make sure it works because we're about to make a histogram. Okay. Histogram is essentially a bar graph with bars that touch, and the reason they touch is because the horizontal axis is a number line that is continuous. So we're going to make a graph that looks like that. Histograms begin with a 0 at the origin and almost always include a break in the scale that immediately follows the origin. The reason is we're almost always going to leap from 0 to the first number, and then we're going to have our class width. As you know, the first number is 604 in our data set, so there's a gap of 604 between the origin and the first bar. But every bar is only 71 units wide. So 604 versus 71, obviously we don't want to have all that white space. So we're just going to put a break in the scale, and then we're going to put our tick marks. Please remember the first tick mark has a number that you have to just get used to. So let's wait for a second there. To do 5 columns, I need 6 tick marks, evenly spaced. So 1, 2, 3, 4, 5, 6, give or take. All right, now, the way in which we're going to scale this, it's kind of particular, but if you remember that in my classes, 674 was the end of the first class, 675 began the second class. That's a gap of 1 value, but it's a number line, so it's continuous. So I want to merge the 2 distances. I want to merge those 2 columns while not affecting actual values. So what's halfway between the end of 674 and the beginning of 675? 674 and a half. Now that's going to be over here, the end of the first column, 674 and a half. It's a half step up. We're going to keep filling out 745 and a half. Mind you, I did not yet label the first tick mark. 816 and a half. 887 and a half. And even though it's the end of it, 958 and a half for continuity. Now, because I'm concerned with continuity, I've said the word like 9 times, I understand that that's a gap of 71, and so is that, so is that, so is that. So this needs to be a gap of 71 also. Now that means, rather than starting out at 604, I actually have to drop it backwards to 603 and a half to make my continuity correction continuous and 71. Continuity corrections are these little half steps we're taking. Okay? Again, more vocabulary for what we're doing. So far as the vertical axis goes, it's measuring relative frequency because I wanted a relative frequency histogram. The tallest or the largest relative frequency in my frequency distribution was 0.3043. So here's what I'm going to do. I'm going to measure off, and my top measure is going to be 0.3, but that bar is going to be just a little bit higher than 0.3 because it's 0.3043. So I'm not going to make it at the very, very tippy top. It'll be like over there. So here's what I need to do. Ready? I'm going to cut it off into tenths first. So let's say that's about a tenth, and that's about a tenth, and therefore that's about a tenth also. So 0.1, 0.2, 0.3. But I'm going to cut those in half also because I want to make it easy to read. So that's 0.05, 0.15, 0.25. I do not need a continuity correction on the vertical axis because I went by 0.05 pretty much all the way up the ladder. So I don't really need a break there. All right, now this is my relative frequency. I will just title it or label it RF. These are my classes. I'm just going to call it class right now because really it's, monsoon rainfall in millimeters, but I don't feel like writing that right now. And there'll also be a title. We'll just call that monsoon. Okay, doesn't much matter, but I'm just going to give it a temporary title. And the classes, the heights of the columns have to obviously match the vertical axis. The first two are the same, 0.2174. So 0.2174 looks like it's around over here. I'm going to just mark it. I'm going to drop a bar there. And I'm going to make it nice and fairly easy to see. Please understand, there's a gap here because there is nothing between the break and the beginning of the first class. Do not make the first bar touch the vertical axis. It should not, pretty much ever. Because it's hard to see exactly where that is, I'm going to write it on top, 0.2174, both times. And I'm going to move forward with the next class, 0.3043, so it's going to go a little bit above my upper mark. Of course, making it very hard to write 0.3043 above it, so I'm going to put it inside, 0.3043. And then I got 0.1739, which looks like it's around over here. And the last one is 0.087. Okay, so I've made the 5 bars, I've labeled each one, I've made sure I paid attention to the continuity correction and the scaling, title, axis labels, everything is there. That's your finished product. Please make sure that when you do a histogram, all of these elements are there, because that's what you'd be graded on. Okay, now distributions can be described, and usually the mnemonic we think about is GSOCS, GSOCS. Okay, GSOCS. It's a mnemonic device. The first letter G stands for gaps. Oftentimes we also say gaps or clusters. So we're looking at the data. Are there any gaps or clusters in the data? Well, there's no gaps in the data because there's no space between bars. Clustering, well, the majority obviously is going to fall in that first 75% here, close, give or take, is in the first 3 groups. I wouldn't necessarily say there's a great deal of clustering and there's no gapping. There's 2 S's, obviously, so you can call it shape, or you can call it the other S for spread. Let's go with shape first. I'm going to talk to you about shape. Now, we talk about the shape of a distribution in terms of a normal distribution. I really wish I had another whiteboard. I'm going to draw over here and then I'll erase it so I can fill in stuff. If I had a distribution that kind of looks like this, it's going to grow, 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 shrink, shrink, shrink. We call that a normal distribution. It is centered. The highest values are in the middle, and it kind of tapers off to both sides. We call that approximately normal. If instead we had a whole bunch of values here and then like low ones like that, it has what we call skew. The direction of skew, because it's going to be either skewed left, also called negatively skewed, or skewed right, also called positively skewed. The direction you choose is the direction of that trail. So does it trail off to the right or does it trail in from the left? This would be skew right because it trails off to the right. This would be, let's say, skew left. Some variation on that theme, that'd be skewed left. So skew left, skew right, approximately normal. There's another one we call either uniform or even. Uniform or even, I mean, it sounds pretty much like what you'd call it. It's basically a column. Columns are fairly the same all the way through. Doesn't have to be perfectly rectangular, but if it's fairly equal all the way through, we call that uniform or even. If it's not one of those, we say it doesn't really have a definable shape to it, okay? This one, what would you call this shape of our actual histogram? Well, it's got some clustering here. There's only one trailing edge off the right. I'd say it's somewhat skewed right, all right? You could also use those adjectives, very, strongly, somewhat skewed to the right. The O stands for outliers. Now there's an actual equation to figure out if a value is an outlier. We'll get to that in another lesson. Outliers are values that fall substantially far away from the bulk of the rest of the data. There's no outliers here, even though there are some high values that are less likely than lower values. It's still not an outlier because it isn't far away from the bulk of the data. It's just at the upper end of the data. The C stands for center. The center could be the mean, if we have raw data to tabulate the mean, or it could be the median, which is the middle data point. In a histogram such as this, the median is pretty easy to find. It's the 50% point, right? So in which class does the median fall? Well, if I just add about 22 and about 22 is about 44, and in this column, we go over the 77% mark. So within this column is the median. It's not because it's the third of 5 columns. It's not because it's the tallest column. These are coincidental to the data. It's because we hit the 50% point within that column that makes it the median. Now, the fact that it's also the tallest makes it the mode, because values fell into that field most often. The mean, we'd have to tabulate all the values, add them together, and divide by the number of terms, which we're not doing right now. The last S stands for spread, which is one of the first things we actually found in this problem. Spread is range. So high minus the low. We already found out way back when, it's a range of 353 millimeters. Okay. That is GSOCs. It's always what you want to think of when being asked a question about describing a distribution. For homework, it's on page 47, which has been attached to the Google Classroom, and its problem numbers 69 to 74. They're all multiple choice. So, obviously with multiple choice, there's no work to show, so I'd like you to put in your honest effort, not random guessing, and see if you can get them right. A reminder, tomorrow is photo day for underclassmen, freshmen, sophomores, and juniors, letters A through L. You take the photos in your math class. Now that's your core math class. If you have no other math class but for AP Stat, you can go during AP Stat. But if you have another math class, which I believe most of you, if not all of you, do have at least pre-calculus, then you should go with that course, because that's going to be more suitable. Let me know beforehand if you have to go during our class. And to be fair, you don't have to go during our class. If you have no other math class, you can go whenever you're free. I'll just tell you how. Okay? Otherwise, I will see some of you tomorrow, and there'll be another video posted with work to do. Please have the multiple choice problems for homework done ASAP, and send them to me if you're not in school tomorrow. Thank you, and have a great day.